Am I audible to everyone? Okay. Right, let us start our today's session. We'll briefly discuss the contents which we learned in Unit 3, and then we will see some more examples of MapReduce programs so that you will get a little bit more idea how to write MapReduce programs. Because anyway, we have discussed 3-4 problems, right? Still we have the time, so that is the reason we will discuss 2-3 more problems so that you can clearly understand the importance of mapper code, reducer code, and as well as driver code, and the role of the record reader, record writer, combiner, partitioner, because these are all will help you to define uh, the solution for a problem in an effective way. Because the combiner itself, it has its own unique features in the sense it will help us the consolidating the mapper logics based on keys, right? So similarly, the partitioner will be useful for splitting the mapper outputs into groups, and those groups will be supplied to the reducer functions. So these all things will help you to better understand the problem and what way we are supposed to develop the code for it. These all things will you are able to understand in much more effective way, right? So for the once again, we'll just look at what are the contents that we learned in unit 3 is uh, yeah. Yeah. So I received some request like this site is not opened while writing assignment question. Don't worry. I'll share. I was already shared Unit 3 material in your group. There you can observe. You can find all this data and the website which is relevant for it. Probably here I was entered some mistake while typing the website name in the assignment questions list. Okay, don't worry. In the unit 3 itself, you can find all this information, and even the code is also available, I think. Okay, so you please go through it and try to analyze yourself, and you just complete that question. Because I received some requests from some of the students that this website is not opened. Okay, so for that you did in the whatever the way that I was specified, right? So initially in the beginning of the unit itself, we have analyzed the data set which we have downloaded from National Climatic Data Center. So here the National Climatic Data Center will maintain the information which is captured by the weather stations in a country. Okay, so here we have the information which it was collected, and from that we'll try to calculate the maximum temperature that was recorded in a year. So for that, what is the data that is available here itself is the whole year's data will be zipped with the name of the year itself, right? So you can extract all the data of all the weather stations. Okay, and from that you need to find out the maximum temperature that was recorded in an year. Okay, so that is our task. For that, we need to analyze what are the contents that are available in the data set itself, and from that we'll try to develop the logic to find out the maximum temperature. So once you observe the data available in the data sets itself is the weather station number, wind direction, longitude, latitude, elevation, visibility distance, like so many attributes of this data set are available. So in this, we'll mainly focus on, we'll consider one of the important is quality code. If it was recorded properly, then we'll get one as the value. So we'll consider only the records whose quality code value is 1. Other than that, we'll consider it as incorrect data, right? So with these assumptions, we have started analyzing the data. So here what we have to do is, initially whatever the data that is available, from that what we are supposed to do with the help of mapper logic, in the sense you have to write the code in such a way. So you need to capture the year and as well as the temperature, right? So these two fields you are supposed to be extracted from the input which it was supplied to the mapper logic. So initially the whole data set is the data format. If you observe, it is a line oriented ASCII format. Each record has many elements. We focus on the temperature element. Data files are organized by date and weather station. So we have the directory for each year from 1901 to 2001, each containing a zipped file for each weather station with its reading for that year, right? So this is the information regarding the data set. So as you all aware of that, record reader, with the help of that record reader, we can convert the given text into key value pairs. Okay, and then those key value pairs, I mean, once you converted it into key value pairs, that need to be split it into blocks, and those blocks will be supplied to the data nodes where the mapper logic, reducer logic, and code, driver code is going to be executed in order to produce the outputs, right? So for that purpose, what way you are supposed to develop the mapper logic is what we require. We need to find out the maximum temperature that it was recorded in any year, right? So here we require two fields. One is year and another one is temperature. So for that, we need to write the mapper code to extract year and the temperature from the data available, right? For example, the first line will be supplied as an input to the, assume that the first line is supplied to the mapper logic 1. Okay, from that what mapper logic has to produce as an output is whatever the year that it was present and whatever the temperature that it was recorded, these two need to be supplied as an output. Here the key value is year and the value is temperature. Okay, so in such a way it need to be provide the output. So this is the input data file format 1990. So this is it is in the form of zip file, right? So this is all information in the year recorded in the year 1990. Like that, all the files are available. From that, we need to extract and we'll try to find out the temperature value. Okay. So for that, what we have to do is here we need to consider, because not only using MapReduce program you are able to produce the highest temperature that it was recorded in an year. You are able to write the same with the help of C++ or C or any other programming languages, right? But here the performance is an important aspect. Suppose, say for example, if you develop the logic by using C language, probably it may take 1 hour or 2 hours or 3 hours of time to produce the final output because huge volume of data, right? So with that, how could we minimize it? Because anyway the data is growing exponentially, we cannot stop it. But even though you have the large volume of data, with the available mechanism, with the help of MapReduce programming model, you are able to produce outputs within no time. That is our target. So for that, we'll try to understand one scripting language, AWK script. Okay, so here we'll write the solution using AWK script, and we'll try to observe the performance difference that exists among the AWT script and MapReduce program, right? So here you can see the AWK code. From that, with this code, what we can do is we'll display the name of the year and we'll extract the year and the temperature. From that, we'll try to calculate the maximum. We'll repeat the loop for all in that year, and we'll try to calculate the maximum temperature using this particular if statement. And quality code, this is also very important. As I told you, we'll consider only the properly recorded data only. So with these two folds, we will verify temperature and as well as quality code if they met these two requirements, and then we'll verify the maximum temperature. Initially we will assign with some minimum value. After that, we'll exchange whenever we find maximum. Okay, so in such a way, we'll repeat this process for all the records in that year, and we'll try to find out the maximum temperature with this line. So this is the code for finding the maximum temperature that it was recorded in a year using AWK script. So this is the expected output for this program itself, right? So here you can observe that it takes 42 minutes on a single EC2 high CPU extra large instance. So when I'm running this system, when I'm writing this code in this particular configured system, it takes 42 minutes of time for producing the output, right? So similarly, now what we can do with the MapReduce program itself is, instead of supplying here, it will take everything as a single file and that will be processed. So that is the reason it took that much of time for producing the result. Instead of supplying the whole thing to the single system, if it's possible to distribute the inputs into different blocks, and those blocks will be supplied to the MapReduce programming language, programming logic, and whatever the results that they are produced, if you are able to combine them, so that you will get the final result, right? So with this mechanism, because this what we learned in Unit 2, how the HDFS is going to be execute a jobs, Hadoop environment, how it supports to execute this MapReduce programs. These things we have discussed in the Unit 2. So this is the information regarding how we are going to be divided into number of tasks and how do we combine. This explains the mechanism which you already know, right? So now let us see how the MapReduce program is going to be developed for this same information is. So in this way, it is going to be converted into key value pairs. From that, it extracts the year and it extracts the temperature, and those will be produced as output by the mapper function in the form of key value pairs. Here key is year and value is the temperature which it was recorded in that, right? So you can observe that so many records are having the year as 1950 and the temperatures are different. Okay, so and then we'll sort and group by, we'll sort and shuffle phase will be applied. So in that, we'll make them into group. Say for example, you can imagine this process will be done by combiner function. Combiner function. What combiner will do? What combiner does is simply all the key values based on the key, all the values for which it is associated will be grouped together, right? So for 1950, you have three different temperatures, 0, 22 and -11. Those will be recorded like this. Similarly, 1949 is having two different temperatures which are recorded in that year. So those will be grouped like this. So this process will be done with the help of combiner. Or you can write your own logic instead of using combiner, right? No issue. And this output will be supplied to the reducer. What reducer does is, the job of this reducer in this task is it need to find out the maximum temperature among these three values. Like that, all the other values which are associated to the keys. For example, in the 1949, you have two different values, 111 and 78. So the reducer logic has to find out maximum of 111 and 78. Similarly, in the 1950, three values are associated for it, and the reducer logic has to find out the maximum of these two. So in this, 22 is the maximum among 0, 22 and minus 11. So finally, the reducer logic will produce the outputs like in the 1949, this is the maximum temperature recorded, and in the 1950, this is the maximum maximum temperature it was recorded. So in such a way, okay, visually, if you see all these things with the help of diagrams, probably it may be easy for you, but the way which you write the code to do like this, okay, you need to habituate that, because today it is one of the emerging area in the today's industry. There are industries suffering with the lack of data scientists. So if you are good enough in analyzing these things, and if you are able to write the code so that you'll become a good data scientist, right? So here nothing will be complicated. Only the thing is what we have and what we require as an output. These two things, if you are able to differentiate, so that you can easily write the code within few lines, you are able to write the code to produce the solution, irrespective of the input size. Irrespective of the input size, you did not bother about the input size, provided if you have the cluster configuration. That means your Hadoop is installed in fully distributed mode. So irrespective of the file size, you can you're able to process it. You're able to analyze it in the way whatever you require, right? So these are the how to write the mapper logic and how to write the reducer logic, and all these things we need to be understand. So the mapper logic just it implements the map reduce base class, okay. It represents the 4 fields, 4 parameters. First 2 parameters, first parameter represents the input key type, second parameter represents the input value type, third parameter represents the output key type, and fourth parameter represents the output value type. So we'll write the code whatever the mapper has to do in the method map, right? So here you can observe that this was the program written in old map reduce framework. So because how can I say that is, there we are using output collectors for collecting the outputs. In the new API we'll use the context objects for finding the for collecting the outputs. So and here the output collector, that means this is long writable key is the input key type, text value is the value type, and output collector which collects the information in the form of text and interwritable, right? So these are the text is the output key format and interwritable is the output value format from the values output, right? And reporter. So this with the help of this reporter object, what we can do is we are able to find out the status of the execution of your program, right? The progress and the status of your execution of your program will be known with the help of the reporter object, right? So here the long writable is same as the long data type in Java, because these things you need to be remember. Into writable is same as Java integer. So text is equivalent to string, right? Because usually we'll use these data types. Other than that also you can use, no issue. So here what we have to do, we need to extract the year from that, because all the data files are in the form of zipped in the form of, so this is the format of the input files. So we need to extract it based on the year, and from that we'll try to extract the lines, okay. In that line what we can do, we need to line in the sense the one record station information. From that information we need to capture, we need to extract the temperature field and as well as the quality code. If those two met, or those two satisfies our condition, Okay, then we'll try to calculate the maximum temperature, and those will be written into the context where we are supposed to write the outputs by using output dot collect method. So in such a way you can write the mapper logic, right? So always you need to remember is we need to extract the line from the input data, and from that whatever the fields that you require, those two need to be extracted, and those will be, maybe it is 2 or maybe it is 3, right? So in that, what will act as a key and what will act as a value, those things you need to be decide yourself, and you need to extract it. That's it. There ends the mapper logic. For example, in the word count program or in some other data, okay, somewhere I think in one of the example, I think in the employees database, which we have discussed in the previous classes, there we have retrieved the gender and as well as the whole record as the value, because there we need to have there we need to extract multiple values in the future. So that is the reason what we did in the mapper logic itself. Simply we'll extract the age, and then for that the value is the entire record itself once again we'll consider, because further we have some processing. So that is the reason we'll extract in such a way. So you need to be decide what you require. So once you decided what you require, so then what you are supposed to do, whatever the line that you have extracted from it, because anyway we need to process line by line the whole information, right? So from that you just extract the fields whatever you require. If it is only 2 fields, like this case we require, we need to extract only year and the temperature fields itself, because by using those 2 values we are going to be find out the maximum in the reducer stage itself. So that is the reason what is the job of the mapper logic itself. Here it need to extract the year and the temperature itself only, air temperature, which is present in the input data, right? So that is the reason why we collect these 2 values from this line only. Okay, so before going to write these outputs, you need to check if you want to check any conditions like this, right? Otherwise directly you can extract and you can place those values into the common areas, right? So in such a way you can write the mapper logic. Similarly, the reducer logic. So reducer logic, the reducer is also implements the map reduce base class. Here it is also requires 4 parameters. 2 parameters represents the output format of the map reduce. That means whatever the type of the output that the mapper logic produce, the first 2 parameters should be of the same type, right? Here, what is the output format? New text year. This is the key. Key format is text, and value format is int writable. So that is the reason here first 2 parameters should be of the same type, and then you can write the text and int writable. Here you need to observe one important point is whatever the input format of the mappers and reducers may not be same as output formats. Mapper may take different input formats and it may produce different output formats, right? Similarly, the reducer logic. So it depends upon your requirement, right? So you can implement the logic. How do you, I mean, whatever the functionality that we have discussed, okay, that should be done by the reduce method will be defined here itself only. So reduce. Here also, if you want to know the status of the execution of your program, you can use the reporter object, right? So here just we will find out the maximum value among the group of values, and just simply will write the year as the key, and the maximum value which we found from the group of values will be written as output value. So this is the reducer logic and the main program. This is what we are calling it as a driver code, right? So here we need to define the configuration object for this job, which is used to specify a specification of the job, and it controls how the job is running, and it passes a class to the job configuration. Here the name of the class is maximum temperature dot class. So this class will be supplied to this configuration, and object. This configuration object will control the entire flow which you have specified here itself, right? Here you can observe the what are the things that we have specified itself. If you are using old API, you need to create a configuration object for the job. See, don't be confused. You can write the program either using old configuration or the new configuration. Whatever the configuration you are using, I mean, whatever the MapReduce framework you are using, you will get the marks, no issue, right? So just for understanding the various versions of the Hadoop, I mean MapReduce framework is available. So that is the reason why we are discussing this. Okay, you can write the program in any one of the by using any one of the program MapReduce frameworks, right? So file input format dot add input path, file output format dot set output path. These two are very important. As I told you, if you are not specifying it properly, if you are not specifying the input path properly, what happens is it is not possible to construct the input splits. Okay, you have stored a file in a D drive. Instead of giving D drive, if you type it as a E drive, what happens in that case? This path looks for retrieving the information from the E drive, but there is no file exists with that name which you have specified. Because of that reason, what it does, simply it stops the execution and it responds with an error message. Okay, so and similarly, output path. You need to specify the output path where you want to write the output of this reduce method, because it is very essential. That means if already the file name which you have specified is already exist, so immediately this program will respond with an error message by stopping the job execution, because it assumes that whatever the path that you have specified here, if it is already exist, that means some other application is created this particular path on which some other application is going to write something in such a way it understood, and immediately because of that reason it stops the execution process. So make sure that whatever the output path that you have specified should be unique. Okay, so you can observe, we'll specify the configuration object also. That means these two will be linked to the configuration object, and after that configuration dot, instead of read it as a conf, I'm completely pronouncing it. Okay, configuration object, configuration dot set mapper class. You need to specify the name of the mapper class. Okay, similarly the reducer class, and you need to set the output key value type and output output key class, and as well as value class, because it uses the, as we have discussed in the first unit, wrapper classes. Some of the classes that requires the information in the form of objects only. So that's why we'll set the key class and as well as value class with the format of the data that it exists. Okay, so here you can observe that in the reducer code itself, what is the output format? Output collected text and interwritable, right? So that is the reason in the driver code itself, you need to specify the output key type is text and output value type should be interwritable, right? You can observe this. And finally, we'll run the configuration object with the help of this run.job configure method, right? So in such a way, you can write the code so that we'll run the program itself. So this is something about how do we write the MapReduce logic for the National Climatic Data Center. Okay, now let us see quickly understand the architectures of old one and the new one, and we'll try to understand the differences, because we need to discuss two more examples in this, right? So in the old MapReduce framework, simply we are call it as a MapReduce 1 or classic MapReduce, where the client is submitting the job. Okay, immediately the job client that will be submit it to the job tracker. Job tracker will do creating new ID for the job and splitting the data into blocks. So this information will be done with the help of job tracker, and the same will be communicated to the job client. Once it was done, immediately the job tracker will assign the task to the task tracker, which is running in the data node itself by assigning the blocks of input data. Okay, on which the task tracker will try to execute the mapper logic and as well as the reducer logics if they are running at the same system. So this is what happening in the uh, classic one map reduce framework. So here the problem is the job tracker is only the primary place which will supervise the execution of the entire program, the entire job itself. Suppose if it gets failed, if it was corrupted, then no other alternative uh, to restart the job once again. All the jobs which are running currently are stopped. Okay, so that is the problem in the classic map reduce framework. So this can be overcome in the second version, that is called as ARM map reduce to framework. Okay, here we'll have the two, I mean, whatever the job tracker responsibilities which we have discussed today will be split it into two demons. One is a resource manager and another one is application master. So they will share the tasks that it need to be performed by the job tracker, even though the job tracker gets failed, because these two components are working independently with coordinating with one another. So if one of the part gets expired, so the others are continuing their process, right? So in such a way, we can avoid the problem which we identified in the map reduce framework 1, right? So here the node manager, map application master are the two important components. They play a vital role in executing the job. Job in the sense they will, you can just imagine they are look like a task trackers. Whatever the responsibilities that the task tracker will have, all the responsibilities are fulfilled with the help of node manager and map reduce application master. Application master will be created, only one application master will be created for the task itself, right? So that is something about the yarn map reduce framework. And so these are some of the differences that exist between old and new APIs. In that, one of the important difference that we have already observed is in both APIs, key value record pairs are pushed to the mapper and reducer. But in addition, the new API allows both mappers and reducers to control the execution flow by overriding the run method. This we have seen physically how it will be implemented by overriding this run method, how we are able to control in the sense there also you can specify the in the previous program itself we just define the output to key class and output map class, sorry, value class. But with the help of this run method, one can set the key value types of the mapper logic and as well as the reducer logic independently, so that you can restrict the program itself to produce the other than that type of format. Okay, so in such a way you can control the mapper logic and as well as reducer logic with the help of run method. This is which we practically experienced with this. So whereas in the old API we are able to control only the map logic, not the reducer logic. For the map logic we can control by using the map runnable mechanism, right? And so another important difference that we experienced is the new API makes extensive use of context objects that allows the user code to communicate with the map reduce system, right? So the new context, for example, essentially unifies the role of job configuration and the output collector and the reporter from the old API, right? So with the help of these context objects, we are able to collect the outputs and we use the job configuration object and for the reporter also because for generating the outputs also context dot reporter of, because in that particular context whatever the status or whatever the number of records are processed by the reducer logic or the mapper logic that we have discussed, right? So in order to get the status of your job execution is also will use the context objects, right? So like that we have identified some differences between old API and new API. Don't worry, we'll experience all these differences in the upcoming. Of course, this is the last one is also we have experienced difference. Output files are namely a little bit different. Part 4 zeros. Sometimes I show you while executing the programs, not executing, while discussing the outputs of the programs, part hyphen 00000. So that is the old API format. Even in the new API format, part M 000 and part R. Part M specifies the mapper and part R specifies this particular one, right? So in such a way you can okay. So we can see the just only a format is different. That's it. With this, we can see the different parts of outputs. As while explaining the partitioner example, there you have seen how many number of outputs. There we have split it into 3 groups. The people are split it into 3 groups, and we have produced 3 different outputs. So while viewing those outputs, you have practically experienced how you have defined this part R hyphen 00000, right? So this way the two map reduce frameworks are differ with one another. So we'll see some other differences in future. So with this I'll stop this explanation, and we'll see how some other problems related to the MapReduce framework we'll discuss now. So my screen is visible to you. My screen is visible to you. Anyone of you? My screen is visible to you. Is it visible to you? Okay. Okay. All right. So this is another example which I was given as an assignment to you. We have telephone company data. So in that we have from number, to number, and the date which they made a call, and call starting time, call ending time will be there, and STD flag. So STD flag defines whether it is STD call or not. If it is represented with 1, then it is an STD call. Otherwise, it is a local call, right? So with this data, what you are supposed to find out, you need to find out the STD calls, those who made greater than 60 minutes, right? So this is the phone number which they made a call to the STD, and if it is greater than 60 minutes, you need to display it, right? Otherwise, you need not. If it is less than 60, you need not display, even though it is STD call. Even though it is STD call, you need not display, right? We need to display only who are making more than 60 minutes of STD calls, right? So that is the job which we have to do. So for that, what way we can write the mapper logic, and what way we can write the reducer logic and driver code, we will see now. So here I was defined some of the constants which are used in this program, from phone number 0 to phone number 1, call start time 2, call end time 3, and flag 4. So here I was taken these constants, and these will be used in the program itself. So now let us see the mapper logic, map method. So text phone number is equals to new text, which was accepted as a string. Long writable duration int minutes is equals to new long writable. Here I was created another variable duration in minutes, right? So now what we did is we'll extract the phone number and followed by the duration. The same phone number may be made a number of calls to the STD people, and they may speak more than, sometimes they may speak more than 60 minutes, sometimes they may speak less than it, sometimes they may speak to the local. So we need to be differentiate later. First of all, what we have to do, we need to extract the phone numbers and followed by the duration which we need to calculate. How much time? Because that is the materialized one. Okay. So now let us see the code, how the map logic has to implement it is string parts value dot toString dot split off this particular. That means whenever if you observe the this particular symbol, okay, so that will be splitted and those will be stored into the parts. It is a string array, right? It consists of set of strings as an element, right? If parts of CDR constants dot stdf log. CDR constant, what is the name? It is the name of the class on which we have 4 variables. Sorry, 5 variables, right? So in that I was taken the last one std flag. CDR constants dot std flag that equals is ignore case equals ignore case 1. Okay, if it is 1 equals to 1, then what we have to do, phone number dot, because if it is 0 you need not consider anyway because they are the local calls, it's waste of your efforts. You need to calculate only the STD calls and the duration of that call should be greater than 0. That we will do later. First we need to extract only the STD calls information only. For that what we have to do is we need to verify the condition like this and then phone number dot set, okay, parts of CDR constants dot from phone number. That means parts of 0. What is the part of 0 here itself? The from phone number. Part of to phone number is 1. The index. Here what we did, parts, we'll split it into one after another. The first part will be whenever if you observe this particular symbol will be split and that will be stored in parts of 0. And next time whenever it observes this particular symbol, that will be stored in parts of 1, parts of 2, parts of 3, parts of 4. Right? Parts of 1, 0 represents the from phone number. Am I right or wrong? Here it is the line. This is the first symbol that it has appeared. So before that, whatever the content that is present, that will be splitted and it will be stored in parts of 0. And next, parts of 1 and the duration. Okay? Duration need to be calculated because we have call start time and call end time. We need to calculate the duration, right? And last one is STD flag. As of now, we are not processing the duration. Just we are processing only. We just want to know whether it is STD call or not. So in the mapper logic, what it has to do? What is the phone number which makes STD calls? Okay, how do we decide whether it is STD flag class or not? Based on the STD flag value which is available at parts of 4th location, right? So phone number dot set parts of CDR constants from phone number. So this whole information will be represented. You can write instead of defining these constants, if you remember what are the values that are present in this input text, simply you can write the parts of 0. Parts of 0 will be set for the phone number, string call end time, call start time, okay, and long duration is equals to 2 millis of call end time minus 2 millis call start time. Here we have defined a method called 2 millis, okay. What it does is, here it is the code for the 2 millis. What it does is simple date format is equal to new simple date format of one date format we have taken, okay. If date FRM is equals to format that parse of date. So whatever the date that we have extracted, so that will be stored into this. Okay. And here what is the intention of this is, here you can observe that these two things should be in the one format so that we can calculate the Because suppose if one format is DDMMYY, another format is MMDDYY, how can we subtract the values? It is difficult. So in order to set it into the specific format, okay, and we make this 2 millis method, and with that what we did, so whatever the 2 millis, that means whatever the date which you have specified in that, call anytime, that means this part, right? From that we'll extract the, because somebody may make a call at 11:30 p.m. of tonight, and they'll continue their discussion up to 1 a.m. of tomorrow. What happens in that case? The dates are interchanged, but still, is it a STD call or not? Yes. And there we need to calculate the duration or not? Yes. And if it is STD call, we need to consider it or not? Yes. So in order to do all these things, we did like this, and duration in minutes dot set. Here we'll get the information in the form of seconds, that you need to be converted it into minutes, because here our condition is greater than 60 minutes, more than 60 minutes. So that is the reason we'll convert it into minutes, and context dot write whatever the phone number that you have extracted and whatever the duration of minutes which you have calculated, these two will be supplied as an output, right? And now reducer logic, what it has to do, it need to calculate, we have what we have, the information as an input of the reducer logic here, and followed by the duration, right? From that you need to check whether it is greater than 60 or not. If it is greater than 60, you just place it as an output, right? For that what we did is, for long writable value, what is value contains? What is value contains? Text key followed by the set of associated values. That means key, for example, from phone number. It may make n number of STD calls on the same day or some other day. Okay. The list of calls whose duration, okay, list of STD calls, not duration, list of STD calls, and the duration will be supplied to this, right? And from this we need to extract one by one. Okay, and we need to verify if the sum is greater than 60, then context dot write will write the result. So in such a way we can display the whose call duration is greater than 60 minutes. So for that, so this is the driver code. Job is equals to new job of configuration comma STD subscribers. Jar class you need to set mapper class, combiner class, reducer class, and output key and output value class, right? Along with that you need to specify the input path and output path. And last we'll run this particular statement in order to complete the execution. Okay, so in such a way you can write the code for the phone number data, right? Similarly, so here is another data which contains the sales data. Okay, the input data is used, it contains sales related information like product name, price, payment mode, city, country of clients, etc. Right? Say for example, this is the information which we extracted from Big Bazaar, because it was placed in so many countries and so many places in the world, right? For example, or Walmart, like that, DMart, right? So this is the information which we have extracted from it. So from this data, what we are supposed to be generate is to find out the number of products sold in each country, right? We need to be consolidate all the products which are sold based on the country itself. Okay, so that is the data which you are supposed to be analyzed, right? For that you can write, you just think about it and you can write the code for it. What we have to do first, we need to extract the country followed by the products. Okay, so these two we are supposed to be extracted from the input data. Okay, and then we just count how many number of products are sold in that country. We just summing all these things, count, and finally we'll display the country name and followed by the number of products as an output. For example, if you see the output here itself, so this is the output. Argentina 1, Australia 38, Australia 7, like that. The number of products which are displayed, which are sold in the country, you need to be displayed it as an output. So this in such a way you can think yourself, and you just try to write the code for it. Any queries? So this is about MapReduce programming model, how you can write the MapReduce programs. So in that majorly, you need to focus on how to write the importance of mapper code, the importance of driver code, reducer code, record reader, combiner, and partitioner. So once you are confident enough on all these areas, then you are able to write the programs in an easiest way, right? So any queries in this? Anybody is having any doubts, you please ask. And I was shared Google Classroom link in your group to submit the assignments. Okay, all of you should submit all your assignments before end of tomorrow, end of the day. Tomorrow at 5 p.m. you can upload all your scanned copies of the assignments into that Google Classroom. Right? JP sir was added a screenshot how to submit your assignments. So you please follow it, and you just submit the assignments. Okay, and you just and another important point, you keep the hard copies with you, which you are supposed to submit whenever the college reopens. Okay, that's very important. Any queries? In today's absentees are 6, 9, 33, 34, 49, 59, 61, 63, and 83. Right? Okay. So the remaining things which we will discuss in the next class. Now I will end the session. Thank you.